Hello student and welcome to this online lecture on power electronics, and in today's lecture we're learning the series connection and parallel connection of diode. So when the series connection of diode or components are required, and when parallel connection of diode or components are required, we are studying in these lectures. And what is significant with the example we learning in this lecture. So first, what do you mean by serial connection? Serial connection means a side-by-side connection of the two diode or the two components. Suppose if you take this resistance and again this is the second resistance, and if you connect this side of the diode to the another side, so this is a point. So we can say this is a serial connection. So this is a series connection. Again, if you take the two resistance, so this is again one and this is again resistance, and if you connect this component in such a way that one side to the again first side of the one component to the first side of the second component, and second side of the first component to the second side of the second component. So this is nothing but the parallel configurations. So by connecting the several configurations, we can improve the voltage handling capacity of that device in the circuit. So it is related to voltage. And when you connected diode in the parallel configurations, so that time it improve the current handling capacity. It improve the current handling capacity. Suppose we have input voltage, suppose 90 volt, suppose, and this resistance or diode or any component have the voltage handling capacity only the 50. So in that way, or in this case, this single component, this diode or whatever may be the component, cannot handle the 90 volt single. But if you connect this component in the series, two components, so it easily handles this 90 volt, because this 90 volt is equally distributed, that is 45 volt and 45 volt. So in that way, it improves the voltage or current handling capacity. Here is in the power electronics, the maximum power that can be controlled by single diode is determined by its rated reverse voltage. That means voltage handling capacity of the single diode is given by the reverse voltage rated, and it's rated for current. In high power application, a single diode may have insufficient power handling capacity. That means power electronics, is the name suggested that in this field or in this branch we requires high power, and sometimes this single devices is insufficient to handle such type of the power. So in these conditions, we need to connect diode in the series configurations or maybe in the parallel configurations. Again, this is the series configuration of the two diode. The diode is connected in the series configurations. The diode D1 and diode D2. The cathode of diode D1 is connected to the anode of the diode D2, and cathode of the diode D2 is connected to the positive supply of the diode, and anode of the diode D1 is connected to the negative of the power supply. So that means this configuration is in the reverse bias condition. No doubt we can be connected in the forward bias, only we have to connect positive here battery and negative here to the diode. So this configuration make the forward bias configurations. So whatever may be the voltage created across the diode D1 is nothing but the VD1, and whatever may be the voltage we obtain at the diode D2 is nothing but the VD2. Now what happened, we connected the two diode in this reverse bias or forward bias. So this is forward bias characteristics. So again, we are interested in the series configuration only the reverse bias configurations, because in reverse bias we get the voltage handling capacity. In forward bias we get the current handling capacity, because in forward bias diode is on, and when diode is on it handles the current, and in reverse bias when diode in the reverse bias it is off, and when it is off it is related to voltage handling capacity. So in reverse bias or reverse direction, both series diode have the same leakage current. So this is the reverse bias characteristic of the two diodes. and it have the same leakage current, but as shown the different value of the reverse voltage. It can be look the reverse, whatever may be the current flowing from the reverse condition, actually the diode is off, the current is flowing because of the minority charge carrier, and that is nothing but the reverse current. And so this is a reverse current is the same, but voltage created or produced across the diode is different. So diode D1 is created voltage VD1, which is a more than the diode D2. So whatever may be the way applied voltage here is goes across diode D1 and D2. So this addition of these two voltages is nothing but the that voltage. So it improves the voltage handling capacity. So again, this is a advanced configuration of the series connection of the diode. Again, this is connected in the series connection of the two diodes connected in the series diodes. But to share the equal current, or sorry, to share the equal voltage across the diode D1 and diode D2. So we add additional resistors R1 and R2, and value of this resistance R1 and R2 both are the same. Because of the same resistance value, the voltage developed across the resistance R1 is same as the voltage developed across the R2. And this resistance R1 and diode D1 both are in the parallel configuration. And we know that the voltage across parallel is the same. The voltage across diode D1 and voltage across resistance both are the same. And this is nothing but the VD1. In the same way, the voltage created across the diode D2 is the same as the voltage created across the resistance R2, that is the VD2. And because of the same value of the resistance, the same voltage across the diode D1 and D2. So in this connecting the diode parallel to the diode, we can achieve the same voltage across the each diode. Only the value of the current is the changes. Now in this slide, we actually looking the applications of the series configuration of the diode with the example. Now two diode with voltage rating of 800 volt. Now we have the diode D1 and diode D2, and this diode D1 and D2 have the voltage handling capacity separately, individually 800 volt, and reverse leakage current, that is reverse leakage current is 1 milliampere, are connected in series across AC source whose peak value is 980 volt. म्हणजेच आपण काय केलेलं आहे की दोन डायोड घेतलेला आहे, प्रत्येक डायोडचं जे रेटिंग आहे मॅक्झिमम व्होल्टेज हँडलिंग कॅपॅसिटी ती किती आहे 800 व्होल्ट, आणि त्याच्या इनपुटला जे आपण व्होल्टेज दिलेला आहे इनपुट व्होल्टेज ते किती दिलेलं आहे 980. जर त्या ठिकाणी आपण फक्त एकच जर डायोड घेतला असता आणि हे 930 व्होल्टेज जर आपण दिलं असतं, सो दॅट केस दिस डायोड मे बी द डॅमेज, and to avoid such type of the damage we connected to diode in the series. आणि अशा आता डायोड कनेक्शन केल्यामुळे त्या प्रत्येक डायोडच्या अक्रॉस व्होल्टेज काय होते ते आपण पाहणार आहोत. नाउ द रिव्हर्स व्होल्टेज अक्रॉस ईच डायोड, व्हॉट वी आर डिटरमाइनिंग द रिव्हर्स व्होल्टेज अक्रॉस ईच डायोड. प्रत्येक डायोडच्या अक्रॉस जे काय रिव्हर्स व्होल्टेज आहे ते आपण काय करणार आहे तर आता फाइंड करणार. सो फ्रॉम दिस characteristics, IV characteristic of the diode, we can be get the voltage across diode D1 is nothing but the 700. So we have calculated here. So we get the 700 volt, and voltage across diode D2 we get the 280 volt. So this is nothing but the voltage across diode D2 at the same reverse currents of the 1 milliampere reverse leakage current. So in that way, these two diodes, diode D1 and D2, can handle the maximum voltage input voltage 980 volt. If you connect a single diode in that scenario, this diode may be damaged. So by connecting the serial configuration, we can be able to handle the large amount of the input voltage. Now again, so this is one of the example of the parallel configuration of the diode. So this is parallel configuration of the diode. The anode of the diode is connected to the another anode of the diode, and cathode of the both diode are connected to the common to the this AC, maybe whatever the voltage or current source. So because of this configuration, we can be handle the current, maximum current. We can be able to handle the maximum current. So we take the simple example. Suppose, so this is a one example. In this, here is a load. So load is nothing but motor. Suppose this is a motor, and it required the 100 ampere current to work efficiently. Okay, so this is a load, and we require to handle the it required current 100 ampere. So if in this case we use single diode, and that diode या केसमध्ये फक्त आपण जर एकच डायोड यूज केला आणि हा जो डायोड असेल तर त्याचं काय असेल, सपोज करंट कॅरिंग कॅपॅसिटी काय असेल, सपोज 80 एम्पियर असेल, तर काय होऊ शकतो. सो इन दॅट केस the 100 ampere current flows from this diode, so diode may be the damage. तर डायोड काय होऊ शकतो, तो डॅमेज होऊ शकतो. तर त्यासाठी आपण काय केलेलं आहे, तर दोन डायोड हे पॅरलल मध्ये जोडलेला आहे. त्याच्यामुळे काय होऊ शकतो की हा जो डायोड आहे तो मे बी द व्हॉट हॅपन्स, इट मे बी हँडल द 60 ampere current, and this diode may be handle the 40 ampere current, 40 ampere currents, and the diode have the maximum current handling capacity of the 80, so it easily handle the 80 ampere current. Again this diode can be easily handle the 40 ampere currents. So in that way we can be avoid damage of the devices by using the parallel configuration of the this diode. So again this is the same example, फक्त यामध्ये आपण काय केलेलं आहे की रेजिस्टन्स हा जो आहे तो सिरीज मध्ये पुट केलेला आहे डायोडच्या, and because of the by putting the resistance in series with the diode D1 and diode D2, we can be able to handle the equal amount of the current from the each diode. In previous example we have seen that this diode is handling the 60 ampere of the current, and this diode is handling the 40 ampere of current, and the load which is required the 100 ampere of the currents. So in the previous case the unequal current flowing from the diode D1 and D2, because D1 is carrying the more current and diode D2 is carrying the less current. So we can be make equal distribution of the current, that is equal, that means the 50. So 50 ampere current will flow from this diode by putting the resistance value R, which is a little value of the R. Because of that the resistance value is less, that means the current is flow the, so we increase the value of the resistance. So because of that the less amount of the current will be flow from this part, and in this case we decrease the value of the resistance, small resistance, and because of the small resistance the more value of the current will be flow, and equal amount of the current, that 50 and 50 will be flow from this diode D2, and at this point we get the 100 ampere because of the Kirchhoff's current law. The current coming from this branch and current coming from this branch are added to each other and flow from the load, that is nothing but the motor. So the significance of this resistance is that we can be share the equal value of the current from this diode. Okay, thank you.